I want to take a step away from these two species examples and start thinking about what happens when you have multiple species interacting. I talked a little bit about the fact that indirect effects can be important. Now let's take a little look at a case where they are extremely important. So the case of sea otters is a classic case of a keystone species. The way that this system often works is this. If you have sea otters, which are shown in this little blurry graphic here, they have a tremendous effect on sea urchins because sea otters love to eat urchins. And they can absolutely decimate the numbers of sea urchins that you find in an area. Sea urchins, in turn, tend to eat kelp. And if you don't have sea otters present, often what will happen is you'll have an explosion of urchins. Urchins can reach densities where they entirely carpet the bottom of the ocean, and they'll eat everything that is alive, particularly the macroalgae that we know as kelp. What results is what's called an urchin barrens, an area of the seafloor where there's basically nothing green and growing left because the urchins have eaten it all. Okay, if you remove the sea otters, then you get this explosion of sea urchins, you get a decimation of kelp, and what can happen because of that is you lose all sorts of organisms potentially that are associated with the kelp forest. Beds of kelp called kelp forests are great habitats for lots and lots of organisms. And there was much concern off of on the Pacific coast of North America not too many decades ago, because when Europeans first colonized the Pacific coast of North America, they hunted the sea otter widely for their fur, and it was driven almost to extinction. One of the side effects of this was that suddenly urchins began decimating kelp forest ecosystems. The moral of this story is that the indirect interactions that a species participates in can be very, very important. The presence of sea otters doesn't just affect the sea urchins, and the presence of the urchins doesn't just affect the kelp. All of the organisms that depend on the kelp forest are affected by the presence of sea otters, whether or not the sea otters actually ever see or interact directly with those organisms. The otter is known as a keystone species because it is a species whose presence versus absence makes a huge difference in an ecosystem. The term keystone comes from architecture. A keystone is a stone that was placed at the very top of an arch. And that's a very important stone because the way that an arch is held up in days before they had things like, say, I don't know, mortar and cement and I-beams, is that you'd have a stack of rocks on either side. The stacks would lean towards one another, and both stacks would lean on this one single stone called the keystone. If you take the keystone out, everything collapses. And that's what it means to have a keystone species in a system. If you take the keystone species out, everything changes because the keystone species has strong indirect interactions with a lot of the species in that community. Another very important point I want you to take home from this lecture is that indirect effects can be very unpredictable. When people thought about hunting sea otters for their fur, maybe they were thinking about, oh, I worry about the sea otter population declining, but they probably hadn't realized that changing numbers of sea otters would have such an impact on the sea urchins. They certainly hadn't thought about what the sea urchins might do to kelp. Even in some ecosystems that we know pretty well, when we go in and alter the numbers of some kind of organism, often the indirect effects will be surprising because it's very hard to predict the magnitude and even sometimes the direction that the removal of one organism will have, the effect of the removing one organism will have on others in an ecosystem. Okay, disturbance is a very important concept when it comes to communities. Disturbance is the removal of biomass from a community. And importantly, it's the removal of biomass in a discrete, identifiable event, the sort of event that you'd be able to put a name to. So for example, what we're seeing here is some photographs from the 1997 Yellowstone fires. That was a single disturbance. There are some cases where there is not much biomass in a community, but it doesn't qualify as a disturbance. So for example, here's a hot spring. The water here is close to the boiling point. There are very few organisms living in the spring, but that's not a disturbance. There isn't much biomass, but there also isn't a point you can point to and say this is when the biomass was removed. When one individual organism gets killed or eaten by another one, technically, yes, you're removing biomass from a community, but it's not really usually considered to be a disturbance. Usually this would be considered an act of predation, of exploitation, but disturbance is generally something that's going to affect an entire community. However, the community can be quite small. When a tree branch falls, you've removed a certain amount of biomass from a forest, and depending on what it falls on, that can be a very significant disturbance to, say, a community that lives in a 10 centimeter by 10 centimeter patch of lawn here. Sometimes things like plagues or diseases can be considered to be disturbances, but usually they're considered to be in a different category. The disturbances that I'm going to look at now involve the 1997 Yellowstone fires, which were really quite dramatic. I grew up with ads like this in the back of Ranger Rick magazine, which I had a subscription to and read religiously. Smokey Bear was very serious about forest fires, and it was quite clear to the 6-year-old me that they were a terrible, terrible thing. And Smokey is a fairly popular character. You can see him in absurd-looking statues outside some of our national parks. But the message of Smokey has always been the same. Forest fires have got to stop. They're bad. And that's certainly the message I picked up as a 6-year-old, because what I saw were cartoons full of burning trees and scared deer running away and poor little Smokey the cub getting hurt more or less like this. It was terrible when you were 6. And so what forest managers have generally tried to do is suppress forest fires. This has been a major policy in the management of U.S. forests. And it has, like many things that human beings do when we try to manage ecosystems, had some rather unexpected effects. If forest fires are allowed to go unchecked, what happens is something like this. A fire will go through and it will really take out a lot of the stuff on the forest floor. It will scorch the tree trunks up to a height of several feet. Sometimes you'll get flames climbing higher, maybe 20 feet up in the air. They'll really damage some of the smaller trees severely. But you can now see there's a lot of green growth up here. None of these trees have actually been killed. The big trees have not been killed by the fires. And so the disturbance that happens is, relatively minor. What happened in Yellowstone in 1997 was a much more serious event. And the reason it happened was, frankly, Smokey the Bear. For years and years and years, forest managers had been listening to Smokey the Bear and suppressing wildfires. Because seriously, it seems quite reasonable that a wildfire is very bad for a forest. But it turns out that suppressing fires is even worse. Because what happens is that fuel simply builds up and builds up and builds up. There's all this dead wood lying around the ground, getting more and more dry. You get more and more fuel, and when a fire actually takes off at that point, it's not something that goes along the ground and merely scorches the trunks of trees. It can easily rise to be what's called a crown fire, which is when you get 60-foot-high trees that are burning like torches. The fire is up in the tops of them. It is able to take off and be moved by winds great distances at great speeds, and it can be catastrophic for a forest. It's also much hotter than that low burning fire that you were seeing a few slides ago. And so it is able to actually kill adult trees as well as basically bake everything in the soil down to the depth below which you really don't get anything that was living there in the first place. In a nutshell, disturbances are an important part of a community, an important part of an ecosystem. If you change the disturbance regime, that is, the type of disturbances that happen, the frequency with which they happen, or the severity with which they happen, you can really alter an ecosystem, because the ecosystem that you see is probably pretty much adapted to the regime of disturbances that it is currently encountering. Now, fortunately, this is another picture from Yellowstone, well after the '97 fires. Fortunately, there are a lot of fire-adapted species in Yellowstone, and even though poor forest management practices caused a fire to outbreak that was much more severe than what these species were generally accustomed to over evolutionary time, the park has recovered. In fact, in many ways, the areas that burned are healthier than they were before. In fact, in some cases, disturbance can be absolutely vital for the survival of the ecosystem. This plant that you're seeing here is what's called privet bush. It's invasive in much of the southeastern United States. And when I was applying for graduate school, I went and visited a professor's lab. I went and looked in a professor's lab who was doing ecology at the University of Georgia. He lived in a house in a little neighborhood, kind of on the outskirts of Athens, Georgia, and his yard was invaded by privet. It backed up against a woods that the privet invaded a long time ago. And so when I was sleeping in his guest room, he came and roused me out of bed on Sunday morning and said, "Hey, we're going to go do some restoration ecology." And we went outside and set fire to his yard. The reason we were doing this is because the only reason that privet can invade an area is the only reason it has invaded the areas that it's invaded in the southeastern US is because those areas used to experience a lot of fire. Privet can't deal with fire the way that the native species can. And so it would, if the disturbance regime had not been changed, privet never would have been able to get a foothold. And we would only be seeing native species in this particular professor's yard. However, because most people do not like wildfires in their neighborhood, fire suppression has allowed privet to thrive to the point where it's taken over many areas of the forest, and a lot of the native species can't make a living there anymore. This does not necessarily mean that restoration ecology is such a great idea, especially if done by amateurs on an impulse. We ended up pouring a lot of gasoline around this professor's yard. It was, a cool morning. The flames didn't really get going for a while, but once they did and things started drying out and small pine trees started catching on fire, it became clear there was a very serious situation. And while I had a good time watching all the fire engines arrive at this professor's house and put out the wildfire he started, I ultimately decided that I was going to go to graduate school somewhere a little bit safer. The moral of the story here is don't attend graduate school if you suspect that your professor is a pyromaniac. The other major moral of the story is disturbances can actually be really good for an ecosystem.